Hello, good day viewers. In this tutorial, we are going to find a solution to this beautiful question, which reads, we should prove by exhaustion that 5x squared plus x plus 12 is even for all values of x in the set of integers. Okay, what does this mean? It means for every value you pick for x in the set of integers and you substitute it here, you're going to obtain an even number. Is this true? That's what we're going to find out. Suppose we have a set of integers like this. You know, integers are just the numbers on the number line. So we want to pick all of these numbers and test in this expression to see whether we're going to get an even number. So this is a function, right? I can write it as a function f of x equal to 5x squared plus x plus 12. Now I would like to test like 3 numbers at random because we cannot test all the values because there are infinitely many. So for example, if I so wish to test for 0, 1, 2, f of 0 is equal to 5 times 0 squared plus 0 plus 12. You know, all of this will give us 12. Why? Because this is 0, this is 0, we only have 12 left. And 12 is indeed an even number. All right, let's test for 1. If we have f of 1, this is equal to 5 times 1 squared plus 1 plus 12. Let us simplify. 1 squared is 1 times 5 is 5, then 5 plus 1 is 6. 6 is an even number. An even number plus an even number is also an even number because altogether we have 18, and 18 is indeed an even number. Let me test the last one here. If we test for 2, we have 5 times 2 squared plus 2 plus 12. 2 squared is 4, and 4 times 5 is 20. 20 plus 2 is 22, and 22 plus 12 is what? 34. 34, and 34 is indeed an even number. So how can we test all of these values? We know on the set of integers, we only have the union of what? Even and odd numbers. If this is an odd, this must be even. This is odd, 4 is even. 5 is odd, 6 is even. So that is how we're going to test them. So let's test for even. F of even. How can we test f of even? We know even number is defined as what? 2n. Any integer you take, you multiply by 2, you're going to obtain an even number. So let x be equal to 2n. Let's find out. So we have f of 2n to be equal to 5 multiplied by 2n raised to the power of 2 plus 2n, then plus 12. This is equal to 5 multiplied by 4n squared, because 2n to the power of 2 is 4n squared, then plus 2n, then plus 12. Let's further simplify. 5 times 4 is 20. So we have 20n squared plus 2n plus 12. And I think for all of these 3 times, we have a common factor of 2. So if we should bring 2 outside, inside from the first time we have 10n squared, from the second time we have n, from the third time we have 6. And you should know that by definition, this is an even number because it has a factor of 2. 2 multiplied by this will make it an even. So we have seen that all even numbers satisfy this to be true. So what about odd numbers? You know, for every even number you take and add 1 to that, you're going to obtain an odd number. Like if you have 2 as an even number, add 1 to it, it becomes 3, and 3 is an odd number. Take 12 for instance, which is an even number, add 1 to it, you get 13. 13 is an odd number. So we want to test for f and odd, f of odd, which turns out to be what? 2n plus 1. So we're going to declare x with 2n plus 1. So let x equal to 2n plus 1. We want to find out whether if we substitute this into our given expression, we are going to get an even number or not. So we have f of 2n plus 1 to be equal to 5 multiplied by 2n plus 1 all squared plus 2n plus 1 then plus 12. Let us simplify this. This is equal to 5 multiplied by, if you expand this, we're going to obtain the first term squared, that is 4n squared. Second term squared, 1 squared is 1. Then 2 times the first times the second, that's going to give us 4n. So we have 4n. We have plus 2n plus 13, because 1 plus 12 is 13. Let us expand this. 5 times 4n squared is 20n squared. 5 times 1 is 5. 5 times 4n is 20n. Then we have plus 2n plus 13. Let us collect the like terms. This is 20n squared plus 20n plus 2n is going to give us 22n. 22n plus 5 plus 13 is 18. Let's factor out 2. We have 2 outside. Inside we have 10n squared plus 11n plus 9. If you distribute this, you're going to obtain this expression back. And you can see it has a multiple of 2, which implies that this is also an even number, and hence true, right? Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.